Hey guys, welcome back. Welcome to the session 17 of Java Full Stack Made Easy. In the previous session, we discussed about the final keyword, right? And we have also seen how do we apply this final keyword in real time, right? Real world scenarios. Like we have discussed how a final bank account number can be created, which cannot be changed. Then we discussed about what? About the calculator application where we applied the final class, right? So I have also added the assignments related to the same in the repository, so you can go for the inheritance assignments where you will find out the assignments related to inheritance and also related to the final classes. Okay, so I hope you are enjoying this series and you'll continue with the same approach, like you watch the video, practice on your own, and then apply the concepts that you learned in terms of assignments. Now in this session, as discussed before, we will be talking about more advanced concept of inheritance itself, that will be the abstract classes. One of the most commonly asked interview questions will be dependent upon the abstract concept of abstract classes. In this session, I'll try to make it easy for you to understand abstract classes. Where do you actually need the abstract classes? What are abstract methods? What are concrete methods in an abstract class? So let us, and we will also try to put the same in some real world scenario so that it will be easy for you to relate things. Fine. So let's get started. Before we dive into the code part of abstract classes and everything, let's talk about what exactly an abstract class is all about. Where can we use concepts like abstract classes? Okay. So just imagine that I am building a house for my own. Okay. So what I do is I decide what all things I would require. That is, maybe I want a 3 bedroom hall kitchen house, and with that I would like to add a swimming pool and a garden to it, right? So this is my plan, right? So a plan is what? A class, right? Class is just a blueprint, it's a plan. So I have created some class for this. Just imagine that. So instead of creating a class and all, just consider that it is a plan that I have. So now in my plan, I know few things that are concrete. That means I have defined certain things, and there are certain things which I did not define clearly. That is, see, I want a 3 BHK house is what is my requirement. Then I want a swimming pool and I want a garden, but I did not tell you, if suppose you are an architect, I did not tell you where is this going to be located, right? So the location is undefined here. Whether I want on the ground floor itself, I want a swimming pool and then a 3 BHK home and then a terrace garden, or maybe a garden surrounding the building and then a 3 BHK house and then on top of that a swimming pool or something like that. So I did not tell you how exactly I want it, but what I told you is what I want. This is something which I want, but where I want it, it is the question mark, right? So if you try and execute this particular plan, you might fail in, right? So you might say that I will design it like there will be a garden surrounding the house and then on top of the house a terrace swimming pool will be there. So if I come down and tell you that this is not what I was looking for, so you have to destruct it again, right, and reconstruct it. So that will be a problem. So we cannot actually bring this plan into picture because of what? This is actually a incomplete plan, right? It's not complete. The location is not really defined. So you might say that this type of incomplete plans are called as abstract classes in Java. So an abstract class is what? It's nothing but a incomplete plan. Why am I saying that it is an incomplete plan? Is because there are certain things in this which are undefined, which are not completed. So what is not completed here? The location. I did not define the location. Where's the location? I did not just define it. So it's just declared that I want these things, but location is undefined. Now you might be thinking, okay, you're correct. You want 3 BHK, you want swimming pool, you want garden, all that is correct. The plan is incomplete. We cannot create an object of this particular plan. That means we cannot execute this particular plan. Then what is the use of this plan, right? So that is something that comes into our picture. What is the use of this particular plan? The use of this plan is simple and straightforward. That is what, see, I have this plan I want the home to be like, if I define this, if I define the location, I would like to have what, I would like to have a garden like this. Okay, surrounding the home, I want a garden. And then what I want is, I want a building. Okay, on top of this building itself, I want a small swimming pool on top of this. So this is what I'm looking for. Now somebody else might come up and then they can say that what I want is, I want a building like this, and then there should be a garden here itself, and within that garden itself, what I'm looking for is, I want to have a swimming pool like this. So there can be different plans, right? So out of this plan itself, the locations can be defined differently. So one person might like this particular plan, one person might like this particular plan. So what am I doing? I'm actually reusing this, right? So in previous sessions, we talked about in object-oriented programming, if we want to bring in reusability, what concept we bring in? We bring in the concept of inheritance, right? So inheritance allows us to reuse the things that we have already created. Like in the previous sessions, we used an example of calculator and a scientific calculator. So similarly, what we can do here is, we have some undefined plan with us, an incomplete plan. If we define the locations, then that plan will be completed, right? So in such a scenario itself, we will bring in the concept of abstract classes. That is why one of the definition of abstract class says that abstract classes are special type of parent classes that force the child to override certain things, override some behaviors. What is overriding? Overriding is nothing but modifying the behavior of a parent. So we will understand first abstract class, special type of parent, right? So this is used when you have inheritance. It is for sure that whenever you implement abstract classes, it means that you are trying to reuse the things and you are trying to implement inheritance in your code. Then there is a thing called as abstract method. Abstract method. Now what is that abstract method? An abstract method is one that does not have any body. So a method without body is abstract method. Method without body is an abstract method. So what is the use of this abstract method? We will see that in picture. What is that? What is the use of that abstract method? So if you remember this example, what was not defined here? Location was not defined. Okay, so I just declared this location. I did not define it. So that type of methods which you don't want to provide clarity, which you don't have the clarity, then such type of methods can be abstract methods itself. So if it is abstract, then later somebody else can come up and then say, okay, I want the location to be like this, I want the location to be like this. In that case, you can construct it. So this is what the concept of abstract class looks like. Hope you are able to relate this example. So I'll just put this example into the code and then we will understand it. After that, what we will do is, we will take a more realistic example and then see how abstract classes works. And there are certain set of rules also related to abstract classes. We will see even the rules of abstract classes and abstract methods. So let us first understand how do we apply it into the code. So first of all, yeah, like I told you in the previous session, we were talking about the final classes, the final methods, and the final variables. So let's just close that, everything that we have discussed previously. Now let's create a class. Maybe I'll call it as an abstract class, which is just a plan for my construction. Okay, so let's create a class and let's name it as my plan. So I have this plan. In that plan, what all I want is void garden is something which I'm looking for. Okay, so that's one function which is defined, which has a body. I'll just say system.out.println garden, and then I will have swimming pool. I'll just mark it as SP, call it a swim, and then I would like to have a rooms. Let's call it as rooms. So this will be, let's say 3 BHK. And lastly, the location is something which I did not define. Okay, So this will be location and this has to be abstract. So what I will do is abstract methods are the methods without a body. So here is the thing that we discuss, abstract methods without a body. So the moment I write a method without a body, it started giving me an error. So there are certain rules that are associated with abstract classes. What is that? Rule number one, whenever you are not giving any method body, then you have to mark the method as abstract. So if you remember in terms of method, elements of a method, I told you the concept of access modifier. So this abstract is an access modifier to the method. So in that session I also told you, as the session progresses we will learn about the abstract modifier. So one of the abstract modifier I am applying here, and in the previous session also I applied an abstract modifier to a method. What was that? That was final, right? So final, static, abstract, these are all access modifiers. So now I created an abstract method. So an abstract method is created, that means method without a body is created. So there is something which is incomplete inside this particular class, right? So three methods I have already defined. One method just declared, it's not defined. That means the method body is not written. So if you are creating a plan and there is something missing in that plan, that means the part of the plan is missing, part of plan is incomplete. If a part of plan is incomplete, then obviously it means what? The plan itself is incomplete, the entire plan is incomplete. So now first rule is that an abstract method can only be created in an abstract class. So if I put my cursor on this, you notice that abstract method location is in type my plan can only be defined by an abstract class. So that is rule number one. Abstract method can only be created in an abstract class. What does that mean? That means if your plan is incomplete, if your method is incomplete, then it makes the entire plan incomplete. That's why you have to create it inside a abstract class. Okay, that's rule number one. Abstract methods can only be created in an abstract class. Rule number two is that an abstract class may or may not have an abstract method. So see, this is also possible. So why is that? How is that? We will talk about that later, but as for now you just consider that is rule number two. Rule number one is that if a method is abstract in a class, then the class has to be abstract. Rule number two is that a class can have zero or more abstract methods. So let me just add those rules on top of this and then give you this example in the repository so that you can relate to this and then understand the rules as well. So rule number one was what? Abstract method is a method without the body. That's point number one, and can only be created inside a abstract class. Okay, that means it cannot be created in a non-abstract class. It can only be created inside a abstract class. Yeah, there are certain things in Java in which you can create abstract classes, but not into a non-abstract class. Okay, as for now, you just remember this, can be created only inside a abstract class. It cannot be created in a non-abstract class. Now, next point is an abstract class can have zero or more abstract methods. So abstract class can contain even zero abstract methods, like I showed you in just now. I showed you in that example. It is possible to create no abstract methods into an abstract class. It's possible. Now you cannot create an instance of abstract class. So you cannot create an instance of it. Let me go ahead and create a service class for my plan. I'll create a new class. Let's call it as plan service. Okay, so here if I come down and create a main function in this and then try to create the instance of my plan is equal to new my plan. At that time I start getting an error, right? So if I put my cursor, it says cannot instantiate the type my plan because it is an abstract class. So abstract classes cannot be instantiated. You cannot create an instance of abstract class. Why can't we create an instance of an abstract class? Is because abstract class is incomplete, right? So how can you construct an incomplete plan? So that's what I told you in the example also. When I give you only this and you try to construct a home and at the end I did not like it, you have to destruct it again, right? So that is why you cannot instantiate an abstract classes. No object of an abstract class can be created. Now you might say, object of abstract class cannot be created, then what is the use of it? The use comes up into picture only when you are reusing that same plan. Okay, so let's understand that as well. So first let me just put this into the repository for your understanding. So this is my simple abstract class that I have created with certain set of rules there. So part number 1 is correct. So this is our day 17, right? Session 17 in our Java full stack made easy series. So let's create that. Day 17 demo 1 abstract class. So this is an abstract class. I have created a plan, and then after that I tried to create the instance of this abstract class, and then that's giving me an error. Okay, so I'll put this, and this obviously gives us an error. So I'll put that here so that people are not confused when they are trying to practice these things. Error, the rule says you cannot create the instance of an abstract class. So let's put that here on top of this particular line so that people understand that trying to do this will give you an error. Okay, so I hope that now you are slowly understanding the rules of abstract classes and also where to apply abstract class. Now, where should I apply this type of abstract class, right? Which I have just now created. Where should I apply this? These things can be applied. So you don't create the instance of my plan, but what you can actually do is, so you can create another class, and let's say anybody's plan, like let's say John's plan. Okay, John is also planning to construct a house. So now what John says that John also wants, see, this is my plan, right? So in this particular plan, we have this garden, swimming pool, rooms, and the location. So this is something which is common for John as well. Even John wants what? Garden, he wants a swimming pool, he wants the rooms and everything, but the location that John is looking for is different. So what John can easily do is John can say this particular class extends the abstract class, which is my plan. So John is trying to reuse my plan, but in my plan location is undefined. So this class of John is a defined one. That means the class of John is a complete class. So if it has to complete, then it has to actually override the unimplemented method. So I'll just add an unimplemented method, and John says what? The location has to be defined. Okay, what is that? Swimming pool at the top, garden around the building, around the one, yeah, around just the building. Okay, so this is what the plan of John, right? So what John has done is, John, when he extends my plan, it means that John now has 4 methods. What are those 4 methods? The 4 methods are garden, swimming pool, rooms, and then the location is already defined by John. So this way we can reuse that particular class as much as we want. Only this location has to be defined. So now if you are creating an instance of a plan, then what you can do is you can go for the John's plan, jp I'll create, and then I'll create John's plan, and then I'll check John's plan, does they have rooms? Yes, it has rooms. John's plan, does it have garden? Yes, it has. John's plan, then what it has, the location is also defined, right? And John's plan also has a swimming pool. This location was abstract, which is explicitly defined in John's plan. Rest all were already created into my plan itself. So these type of methods are called as concrete methods, and these type of methods are called as abstract methods. Methods that are defined, methods that are undefined. So let's run this, and you can see that John's plan is complete. So similarly, if there can be any other person who can come up and then create an instance on the same type of, on the same plan itself. So let me create another class, and let's call this as Rock's plan. Okay, when I say John, it is John Cena. When I say Rock, it is the Rock Johnson, right? So generally I take these examples. So let's extend this as well. Extends with my plan. So here also I am trying to reuse the plan that I have created, and here once again we can add the unimplemented method, and then we can complete it as per our requirement. Okay, So what John wants might want is, so swimming pool in front of the building, and then what, rooftop garden. That's what Rock's plan is. So similarly, you can just go ahead and then create instance of the plan of Rock. So if anybody wants likes Rock's plan, they will go for Rock's plan. If somebody wants John's plan, they can go for John's plan. So this is how easy it is. So what has come into picture is the abstract classes. The other methods are being reused, and only one method is being modified according to our requirement. So this way we can bring in the concept of abstract classes into picture. So let me also share this with you, where we cannot directly create the instance of an abstract class, but the instance of the child of abstract classes can be created, because child of abstract classes has to be a complete class. If not, if they are not overriding the method, then that class should also be an abstract class. It becomes an abstract class, you cannot create a instance of it. So demo 2 abstract class. So this is my plan first, and out of that plan itself I am trying to perform reusability. So in reusability, what I have done is I have created two classes, John's plan, then Rock's plan as well. And lastly, the service class. And if you think over this, you can understand one more very important thing is that, see, John and Rock, they are utilizing the plan, the abstract plan, which is created here. If they want, they can even change the garden, swimming pool and room. That's because they are all methods which are not final, right? So because they are not final, it is not mandatory for John or Rock to implement it as it is. They can definitely modify the behavior of the parent. So if you don't want the child to modify the behavior of the parent, that's something which we have already learned. So garden cannot be changed, then you can just mark it as final. So what am I trying to say is that a final method can be present in an abstract class. Okay, but an abstract method cannot be final. So if you mark this as final, it means that you don't want this to be changed. Also, you want the child to change, right? So you cannot do that. You cannot say head is also mine and tail is also mine. You cannot say that. So one more rule comes up into picture. What is that? An abstract method cannot be final. Other methods in an abstract class can be final, but an abstract method cannot be final. Abstract method cannot be final. That's the rule. So now when we say abstract method cannot be final, one more point I would like to add here for your understanding. If I mark this method as private, so what happens is I am saying that it is not visible to the child. So if an abstract method is not visible to the child, then who is going to override it, right? Who is going to give the body for that? So that's why your abstract methods cannot be private. If I put my cursor here, again it is giving me an error. The abstract method location and type my plan can only set a visibility modifier, one of public or protected. It can either be public or protected, or it can even be default. That's because if it is default, child inside this package can access it. And logically, if you want this class to be a parent, then you should allow the class to be inherited by other package members also. That's why default is valid. But more importantly, public and protected makes more sense. So let's go here and add another rule. An abstract method cannot be private as well. So it cannot be final, it cannot be private either. So these are again two more important rules. Yes, in an abstract class, methods with body can be final. Okay, and like as I told you in the previous class, a syntax of private final is valid, but logically if you mark this as private, then marking it as final makes no sense. That's because if it is private, it is not visible to the child. So if it is not visible to the child, the child cannot override it. So it's syntax wise it is fine, but it doesn't make much sense. Now coming to this final void garden with a body, it's all fine. So child cannot override this behavior, rest all behaviors child can override, and this behavior child has to override. So I will put this example as well with these two new extra rules associated with the abstract class. So this will be our demo 3. Okay, now I hope that you have got to know in what situations abstract classes has to be used with the example that I have shared here. So abstract classes bring in the concept of reusability, right? And it is a special type of base class which forces the child to override the methods that are created. So as for now, what I will do is I will just close it. You do remember the rules. And abstract class can have 0 or more abstract method. An abstract class cannot be instantiated. Then which means you cannot create an instance of an abstract class. An abstract method is a method without a body, and then an abstract method cannot be final, abstract method cannot be private. So you do remember these rules that I have written here. So as for now, because you have got to know the rule, I will just close it, and we'll try to give you a more realistic example related to abstract classes. So if you remember, I created this animal class and left it blank. Now I want to create this animal class, and imagine a zoo, right? So in a zoo we have multiple animals, and those animals, let's consider that all of the animals they eat, and their sound is different. So that's what we are thinking of. Okay, obviously even the eating habit can be different, and then the way the animals can move can be different. All those things we can discuss later, but as for now, as for the example, we are considering that all the animals will eat in our zoo, and they make different sound. That's what we are thinking of, and we will try to implement the same. So I will add an eat method. Okay, so this will be common for all the animals that we are creating. We'll just say system.out.println animal is eating. That's what I want to add in here. And then there is one more method that is, let's say, void sound. So my requirement, so this is a common, we will consider that this is a common behavior among all the animals. Okay, let's consider it as common behavior for all the animals. Okay, and this one that I'm creating here, this should be an abstract. That means the behavior will differ for every animal that we create. Behavior will differ for all the animals we create. So this sound has to be declared as abstract. Each animal that is creating this sound has to is making a different type of sound, right? So now as the abstract method came into picture, the moment we add an abstract method, then we have to mark the class also as abstract. So let's make it as abstract class animal. So as far as the example is concerned, what we are thinking of is all the animals they eat and they make sound, but all the animals in this case we are considering all the animals are eating. We are not again getting into the detailed of the example, like tiger and all, they are carnivorous animals, and then the deer and all that we have in the zoo, they are herbivorous animals and all that. We are not going in details of that. Obviously if I give you one example, you can break down that example, and then you can bring in your own logic into it. No, hypothetically what we are understanding here is we are creating a situation where all the animals they eat whatever they eat, but they eat. Okay, and when they make sound, they make different sounds. So that's what we are thinking of while creating this particular classes. So let's create, obviously it's an abstract class, object of an abstract class cannot be directly created. And also what I want you to think of is it's an animal, right? Which animal we don't know, right? So an instance of just an animal cannot be created. So now we have a tiger class which is a child of the animal. So tiger also eats, but what type of sound this tiger makes, we have to define that, right? So tiger roars. So I'll just say system.out.println, and then I'll say tiger roars. Similarly, I can have more animals in my zoo, and then I can create different sounds for them. Maybe I have a cat, or maybe a dog, or anything. Maybe a horse, or maybe a giraffe, or a zebra, anything. So let's create another class, add more child classes to it. Let's create a cat, maybe. Well, finish this. This class cat will also extend the animal. Okay. And since that's an abstract, so I have to override the sound method. See, also how do I do it? Just hit a control space, automatically it will tell you that's an abstract method. Sound has to be overridden from an animal. So this is how easy it is. Just hit enter, you'll get the body for this sound, and you have to define it. So system.out.println cat meows, right? Similarly, we can create more classes, like maybe we can add in a dog or a horse or a giraffe, or anything can be added. So as for now, I'll add a service class for this. So I'll call it as animal service with a main method. All right. So here main, here we go. Now let's create the instance of animal, and then also call them. So point number one is that if you remember in the previous session also, I told you how do you actually create the dynamic method dispatching concept. So as for now, I'll go with an easier way. Later I will talk about the dynamic method dispatching, because in inheritance you'll see a lot of dynamic method dispatching concepts. Okay. So let me first create the instance of a tiger. So tiger is an animal, right? So tiger equals to new tiger. So obviously tiger will eat. Okay, tiger eats. So I'll go for tiger dot eat. So it tells me that animal is eating, a common behavior. The animal is eating. Then what I'll do is I'll say tiger dot make the sound. So what sound a tiger makes? Roars, right? So that's what we have written. So that particular function will be called. That's how it is deferred. Similarly, I can create the instance of cat is equal to new cat, and then when I say cat dot eat, at that time it says animal eats, animal is eating. So cat dot sound, so cat meows is what I'm expecting here. So that's how we have analyzed, and that's how we have thought of the method eating, where we thought that the eating behavior is common, and the sound making behavior is different for different animals. So this way your abstract classes can come into picture. So let me just put this example into the repository, and we'll talk more about it. Hope the concept is clear to you. If this concept is clear, we can add in more things into this. Demo 4 abstract class animal is what I will add in here, and we'll take more we can even take more realistic example, but I hope that this is fun, where we are taking animal, tiger, cat and all that, so that we can understand it and we can visualize the things in real time. Now in this example, obviously we talked about the same old rules, that is an abstract class can contain an abstract method, and we also talked about abstract classes. They are special type of base classes. They force the child to override the methods and all that. So that is something which is already discussed. Now let's talk about the concept of dynamic method dispatching. That means creating the object of a parent, and then creating the instance of a parent, and using the object of a child with it. That is, if I say animal here, and I'll create the instance of animal, and then I'll say animal eat and animal sound. Okay, similarly for this also I can create animal 1 that also eats and makes the sound. Okay, let's save it and run this, and you'll get the same result. Okay, the result is same, but what am I doing here is I am creating the object of the child object is created at the right hand side, right? Object of the child, referring it with the parent instance. This is fine because tiger is animal itself. Because tiger is a child of animal, this is possible. Whenever there is a relationship, it is all possible creating like this. If that means if the type is same, then this is possible. The type of tiger is animal only. How do we check the type of that? We can just say system.out.println. There is one special keyword available into Java that is called as the instance of. So if instance of like animal instance of, if you say tiger, we are checking whether the animal is an instance of tiger or not. So animal, yes, it is an instance of tiger, so it returns you true. So that way we can create the instances. If it returns you true, then you can create things like this. Okay, so I'll just give you this one and I'll call it as instance of, or maybe dynamic method dispatching demo 5. See, concept of this dynamic method dispatching, you can relate it with the vending machine, coffee vending machine. So it is decided at the end whether you want the milk or maybe a coffee or how much sugar. That is decided at the end, right? During runtime, it is decided what you exactly want to call. So I will just try to extend this example and make it easy for you to understand and appreciate the concept of dynamic method dispatching. Okay, so for that, what I will do is I'll remove everything. Okay, I'll create one class, or maybe I'll bring in another concept here, that is more abstract methods we can bring in. So let's create abstract void a move method. Okay, so when I say that I'm adding a move method, so I mean that each since it is an abstract one, so I'm thinking that each animal that I create moves differently. That's what I'm thinking of. If the method body is created, then it is a common behavior. If a child wants to modify it, they can modify. If not, they have the option to not modify it. And if I don't want anything to be modified, I can just mark it as final, which is something we have already learned. So I have created a move method. So I'll go to tiger and then I'll add that method move here, add the unimplemented method, and inside the cat also I want to add the unimplemented method. So for tiger, I'll just do a system.out.println. So I'll say tiger is moving, right? So tiger runs jungle, okay, and runs fast, or maybe in the jungle. And similarly for cat also, I would like to override this move method. It's already overridden, so I'll just add this, and cat runs, maybe let's say silently, okay. And what they do, and they jump around, they have fun, right? So let's save it. And now in the animal service, what I'm creating is, so as per now, see, I'll create another class, or maybe I'll create another class here. So see, by this time when I'm creating this particular class, there will be one mover, animal mover, okay, and the responsibility of that animal mover is to move the animal. So I'll create an animal mover, and this animal mover, I'll create a function whose behavior, whose responsibility, void move animal. Okay, so when I'm creating this particular method move animal, I don't know which animal this mover has to move, right? The responsibility of this mover is to move the animal. So it can either move the tiger, or it can move the cat, or maybe a dog, or maybe something that I create later also. So in that case, what this mover would say is that I'm gonna move an animal. Okay, so I'll do this animal, and I'll just say animal dot move. Here I'm not specifying which animal has to be moved, right? So what I'm just telling is that animal has to move. Which animal, I don't know. So that is defined at the runtime, which animal has to be moved. So I'll come to the animal service and I'm trying to make the animal move. So whose responsibility it is to move the animal? It is the animal mover who has to move the animal, is equal to new animal mover. So animal mover dot move animal. Which animal has to be moved? You have to define it here. So I will create the animal here. Animal equals to new. If I say tiger here, you see that animal move the animal. So which animal now the mover is moving? It will move the tiger. You can see tiger runs fast in the jungle. If I create, instead of creating a tiger, if I create a cat, so this mover is capable to move the cat as well, right? The cat silently runs. So while I was creating this animal mover, I don't know that the dog class also exists. Do we have a dog class here? We have not created it yet. But we have already done with the mover. The mover's responsibility is to move the animal, whichever animal it is. It can be a cat, dog, maybe a rabbit or anything. Okay. So what I will do is I'll create another class here and call it as a dog. I'll create new class and this is a dog class which I'm creating. So dog, is it an animal? As for now, no. Until and unless I extend it with the animal class, it's not gonna be an animal. So now dog is an animal. So dog's responsibility is to override all the unimplemented method, the move method, the sound method. These are two compulsory methods which the dog has to override. So what we will do is we'll again go for system.out.println and we will say dog runs happily and what, moving its tail and all that. So we can just add in more things in there. Then the sound of that dog is what? The dog is just gonna bark, right? Dog bark. So let's save it and I'll go to the animal service. In mover, you remember I did not change anything in the mover. So I'll just create the instance of dog, which is actually created after the mover is created. So animal new dog. Now the mover is created so dynamically that it can move any animal, even it can move the dog. Okay, so this way we can create movers, animal movers, and perform dynamic method dispatching. See here I am performing what? Dynamic method dispatching itself. I am saying animal move. Which animal moves? I don't know, right? So here I don't know what animal is moving. See, if you pass the instance of tiger, it moves the tiger. If you pass the instance of cat, it moves the cat. If you pass the instance of a dog, it moves the dog. So that way your dynamic method dispatching comes into picture, and also it is useful when you're creating real world applications. Hope the concept of the dynamic method dispatching is clear to you, and also where should we use this dynamic method dispatching is clear to you. There's one rule that is associated with the dynamic method dispatching which you have to know is this. Whenever you are performing a dynamic method dispatching, you should ensure that the methods of parents can only be called, not the child specific methods. Now what do I mean by that? Suppose now I have this class animal where I have the eat method, sound method, move method, and then I am creating another method for tiger. Okay, so I'll say void hunt method is created inside the tiger. I did not create a hunt method inside cat and the dog. System.out.println tiger is a hunter. Okay, that's what I'm creating here. And when I now go to this animal service, and you see this animal is equal to new dog is created. Instead of dog, I'll create it as tiger now. Okay, so let this be dog. I'll comment this and uncomment this one, and here I come and then I say animal dot. If suppose I try to call a hunt method from tiger, I'll not be able to call it. You can see it here, hunt method, the method hunt is undefined for type animal. It's not saying me that it is undefined for the type tiger. It is saying me that it is undefined for the type animal. So this tells us that you can only call super type methods, meaning what? Parents methods, not the child specific method. If you want to call a child specific method, at that time you have to create the instance of tiger with tiger class itself. You cannot do this. That will not be possible. But if I do a t.hunt, now it is all possible. See, I can call a hunt here, but here it will give me an error. That's because whenever we are performing dynamic method dispatching, at that time this child specific methods will not come into picture. There is again a logical thing behind that. Why is that? That's because, see, if you create things like mover, at that time you know that animal can move, right? But do you know there is something called as animal.hunt? If you go to animal, you don't have anything called as hunt here. It is there in tiger. But how would somebody who is creating the class today knows the method which might be created after 10 years, right? So the animal, when I was creating this mover, I did not knew that there would come a class called as dog, right? So while creating this, I know only animal. I don't know the child specific methods. So whenever you are performing dynamic method dispatching, you should ensure that while creating this type of objects, when you are creating the object of a child and referring it with a parent's instance, you should ensure that only the super type method, that means the parent type methods can only be called, child specific methods cannot be called. So I'll put this entire example into the repository for your reference. I hope I'm pretty much clear about the concepts that I'm talking about, and you are able to relate this even to the real world situations. Animal class extended. So here is your class animal, where I have added one more method called as move, and then inside the tiger I have added a child specific method hunt, which is not part of the parent. Then I have the class cat. Dog class I actually created after creating the mover to show you that it is also possible to now create. You can create any animal, and this mover will be able to move any animal. Even if you create it after 10 years, it will still be able to move that animal. Then I created the dog, and lastly the service. So any common behavior you have, you create it inside the parent. If you have a child specific behavior, you create it inside the child. If you want the standard functionality not to be changed followed by all the child, then you make it final. Okay, so this way we create abstract classes, mark some methods in an abstract class as final and all. So I will give you one last example, more realistic one, and then after that we will be done with the concept of abstract classes. So I'll just clean up everything, and first let's think of the example that we are trying to implement, and then after that we will implement the same into our application. So consider that we are creating a bank account, okay, a class as a bank account, which is common for two type of accounts that we will create later. What type of accounts we have? We have a savings account, and then we have a current account. Okay, so obviously the current account has a different set of rules, and the savings account has a different set of rules. So this is what we are trying to implement into our application. Let's see how can we bring in the concept of abstract classes in such situations. So I'll create first a generic class, which is a parent class, basically an abstract class. I'll call it as bank account. Okay, so bank account, both savings account and the current account, both will have some common behaviors, right? So what type of, but the common behaviors might again what, yeah, common behaviors will be there, and then the different type of bank accounts will have different set of rules. So what I will do is I'll create a bank account, and I will create some account number here. Okay, and then also I will create a balance. Okay, int balance. It will be better if I take it as a float or a double, because obviously the balance can be a lengthy one for riches. Okay, so now what I will do is I'll just try and create the old things. Maybe I'll create a constructor using field for this, so that I can initialize the bank account and the balance while creating the bank account itself. So constructor using field. Whenever I generate the constructor using field, I told you that it is always a good practice to bring in even the default constructor, because I want anybody to create the child without passing in the values and also by passing in the values. But if my requirement is that the object of bank account can only be created after adding the bank account and the balance, at that time I may skip creating this default constructor. Okay, because we have already seen how a super can be called, and if there is no default constructor, explicit call to super must be done in our previous sessions. So what I will now do is in this bank account I will create something called as deposit, void deposit function. So this deposit function will be common, which will have the same set of rules maybe. Okay, for both the account type, maybe a savings account and maybe a current account. So here I'll try to deposit the amount, and whatever amount is being deposited, I'll say int amount. Okay, and the functionality of deposit, that will be what? The balance that we have will be plus equal to, that means balance is equal to balance plus amount. So that's what I want. And they can print a message, the amount, the deposited amount is so and so, or your balance is so and so. Deposited, how much, whatever amount you are passing, amount in your account. Okay, deposited so and so in your account. That's fine. So this is deposit. I can also take a account number and then I can specify the account number and all that. But as for now, let's just keep it simple. Okay. And also I would like to add in another feature, common feature for savings account or the current account, which is going to be check the balance. Okay. One is deposit. Another one is check balance. Okay, and for checking the balance, you can take the account number. Okay, so that based on that particular account number itself, you can display it. You can extend it, taking the array and store all the bank accounts and all that. But as for now, to keep it very simple, I'm just checking the balance. So check balance, and I'll just say balance in your account is plus the balance. Okay, so likewise, what I'm now trying to build is that I'm trying to perform a withdrawal. Okay, I did a deposit, I did a balance check. Now I want to withdraw the money. Here comes the concept of abstract class, where you withdrawing the amount from a savings bank will have a different set of rule, and withdrawing the amount from the current account will have a different set of rule. We will understand what rule we are going to implement it there. So let's create the abstract void. What is that? Withdraw function. So when I'm trying to withdraw anything, I'm trying to withdraw. Sorry, when I'm trying to withdraw something, I'm trying to withdraw an amount. So let's say int amount is what I want to withdraw. So this is an abstract method. Abstract method has to be a part of abstract class itself, right? So why am I creating this abstract method? This will have different rule for savings and current account. So that's what I'm thinking of. We'll have a different rule. So because the method is abstract, the entire class has to be abstract. That's the rule we have learned. So this way I have now created a simple bank account class. So from this bank account, we will have two type of accounts created. So what is that? So let's just create it. Create a class. Let's say savings account. So that's what I'm creating now. Savings account. This will extend the bank account itself. So savings. Oh, sorry. So it should be account. Anyways, create it here. then try to rename it in the file to saving accounts. Good. So now this actually extends the bank account itself. Okay, so when I extend this with a bank account, I have to first override all the unimplemented methods. That means all the abstract methods has to be overridden, and all the other things will be the same itself, right? So it can inherit all the behavior. It can inherit the behavior of deposit and check balance. Withdraw is abstract, so I have to give the body for withdraw, and we know that it cannot inherit the constructor, so we have to create a constructor here also with the same type of stuff. So let's include that. Source, generate constructor using field. Oh, sorry, I need to have the constructor with the fields, right? So I don't have the fields here. The fields are actually from the parent, okay, which is select super constructor to invoke. Bank has this, the account number and that. So let's generate that and we go here. So what happens is we'll have a constructor, we'll take the value, account number and the balance, and that we will pass to the parent. Okay, this means we are basically initializing this account number and the balance. Now we have to override the unimplemented method, that is withdrawal. Rest all methods will be here itself. So what I will do for withdraw is that I have a rule here. What is that rule? The rule is that whenever I am withdrawing something from a savings bank account, I want the minimum amount to be there in a savings account should be like minimum 500 has to be there. If your balance is 1000, you can only withdraw 500. 500 has to be a minimum balance. I'm not allowing you to withdraw that 500 rupees. So that is the rule that I have for savings bank account. So how will I implement this withdrawal for that? So if first you check the balance, okay, we are doing what balance minus amount is what we want to do. Okay, this is a normal practice that we do. You check balance minus the amount. So what I want to also check is that you have to check the balance. It should be minus, when you are doing it should be -1. You should also check that it should be greater than equal to 500. The remaining balance should be greater than or equal to 500. So by this logic, if this is satisfied, so what am I checking by this? I am checking the minimum balance to be 500. Okay, let me just put a comment on this and make sure that you understand this. Check minimum balance is 500 after withdrawal, then only allow withdrawal, or else don't allow the withdrawal is what I am saying. Okay, then in that case what you do is balance is equal to balance minus amount. So we can just say minus equal to amount, so which is same as writing what balance is equal to balance minus amount, and then we will say system.out.println withdrawal of rupees the amount. Okay, whatever amount you have given, so that much you can withdraw. If the minimum balance is not there, then we'll give a message to the user saying that there is insufficient balance into your account and you have to maintain the minimum balance of rupees 500. System.out.println, here we go, and we'll say insufficient balance, and please maintain rupees 500 minimum in your account. So that's what I want to say. So one rule is for savings bank, so which I have implemented, right? Specifically it was for savings bank account. Rest all thing like depositing and withdrawal and all that is same itself. Okay, so now what I will do is similarly I will create one more type of account, that is going to be a current account. Then the current account, there is no rule for minimum balance check. Current account, and this current account will also extend the bank account and it will have the common functionality, right? So what are the common functionalities? The common functionalities are same like deposit, check balance. So what is the abstract functionality there? Withdrawal, right? So withdrawal rules will change here. So what I will do is I'll just copy everything that I have written here and then modify the same. That will be easy for me. Also, I always tell my student that the best programmer is one who knows the best copy paste technique. Okay, so instead of the saving account, let's make it as a current account because it's a constructor. Constructor should have the same name as the class name. So here we go. That problem is solved. Now for withdrawal, I'm not going to check the minimum balance concept. So what I'm simply doing is try to perform withdrawal if the amount is less than or equal to the balance. Then what you do is perform the withdrawal, that is balance is equal to balance minus the amount. Else you just say insufficient balance. No need to check for the minimum balance. Okay, that's it. So these are the two rules that I have implemented. So now what I will try to do is I'll just save this and try to create a service class for the same and try to create the instance of the savings bank account and also the current bank account and check the concepts that are implemented properly or not. So let's call it as banking service. Let's have a main method in it. Here we go. So now I'll now create the instance of the bank account itself. Bank account, let's call it as saving account equals to new saving account. Sorry, the new saving account. Okay, now while creating this saving account, I have to provide in two things, right? The account number and also the amount. If you go to the saving account, so what I should pass in? I should pass in the two things, which is the account number and the balance. So which goes here, the account number and the balance. So account number is of type string. So I'll call it as SV for saving account. Let's just call it as 123 savings account 123. The balance here is, let's say the balance is 1000 rupees. Okay, and similarly I'll also create a current account. So let's call this as current account and create an instance with the current account itself, and we will call this a CR123 and we will put the balance, maybe some 2000 rupees we will put into the current account. Okay, now let us first try and deposit the amount into savings bank account and we will perform a withdrawal and we will also check the balance after withdrawal. Okay, so our first account is the savings account dot. I want to add the amount into it, deposit the amount, and before depositing the amount, I'll say savings account dot check balance. So first I will check the balance. Let's check the balance, save it, run it. So the balance in your account is 1000 already. So here is what I have added, 1000 rupees there, and I will deposit something into this. Maybe I deposit some 500 rupees into it. So after adding 500, if I check the balance, it will be 1500, right? So after 1500, I will try to perform a withdrawal. Okay, savings account dot perform the withdrawal. We know that there is a minimum balance rule there. So let's try and withdraw 900 rupees from 1500. So balance should be 600. So let's check the balance after this. It has performed the withdrawal. And if I check the balance, so that will be 600. If I perform another withdrawal on this, maybe I'm trying to withdraw another 300 rupees, and after that I'll try to check the balance. Let's save it and let's run this and check. So it says that the balance is still 600 because this one withdrawal has not happened because of what? Insufficient balance. It says please maintain rupees 500. I have written 00. So let's go to savings and write that message properly here. Please maintain rupees 500 minimum in your account. So that's what it says. Okay, similarly what I will do is in the current account also, to make it easy for you, I'll deposit 100,000 itself, and all this functionality I will implement with the current account. So system.out.println current account. So I'm doing the same thing, everything is same with the current account. Okay, so I'll perform a balance check for current account, which is 1000 again. I am depositing 500, that makes 1500. Then I will try to withdraw 900, so that should become 600. I'll check that balance again. Then from 600 rupees, I'm withdrawing 300 rupees, and after that I'll check the balance. So for current account, there's no minimum balance rule which we have implemented, but for the savings account, we have implemented a minimum balance rule. So let's save it, run this, and test our application. So you can see that for savings account, it is when I try to withdraw the amount which exceeds the minimum limit, it is showing me please maintain rupees 500 here. But here it is not doing that, and also current account, it is not the savings one. So current account should have just 300 after the withdrawal of 300. So this way you can see how we can implement the concept of abstract classes into real time. So I hope that you have understood the concept of abstract classes. Where do you actually put the abstract classes into real time, right? Where in this example we created a bank account, and we knew that there will be two type of bank accounts, the savings bank account and the current bank account. They will share the common behavior like depositing the amount and checking the balance, but there will be one different behavior for both the type of accounts, that is withdrawal. In terms of savings bank account, the withdrawal rule is that the minimum balance 500 has to be maintained, whereas in the current account that minimum balance will not be maintained. So that minimum balance is where what we are checking in here, balance minus amount should be greater than equal to 500 is what we are checking. And in the current account we are not checking that, we are just checking that balance should be less than equal to balance, right? So in that case we are performing that withdrawal. So here it should actually be the amount should be that, okay, not the balance. So balance cannot be less than equal to balance, right? So it should be amount should be less than or equal to the balance that we have. In that case you just withdraw it, okay. And then lastly what we have is we have the banking system where we are performing the withdrawal. So rest all things, it's common, the depositing, whatever you deposit it gets deposited, right, in both the savings account or be it a current account. So whatever amount you are depositing, it deposits that. And in check balance, it just shows you what balance you have now. But whereas as far as this withdrawal is concerned, in savings account we are checking the amount is minimum 500 or not. After withdrawal the balance should be minimum 500 or not. So if it is, then perform withdrawal, else don't perform the withdrawal, just say that. In terms of current account, we are not checking that. We are only checking the amount withdrawal is less than the balance that we have. If it is less than the balance or equal to the balance that we have, perform the withdrawal. So this way we can bring in the concept of abstract classes into real time. If you have any doubt on this, you can obviously comment on the video and ask me the question related to this. And I always try to make things easy for you and also make it more realistic. Demo 8 bank account demo for abstract class. This is my abstract class, bank account, then the savings account, and then the current account. Also after this session I'll be adding assignments related to abstract classes and all. You can go through with the assignments into the, you can find the assignments into the repository, the assignment repository which we have created before. So done with this. Fine, more of the abstract. Obviously we have learned a lot about the abstract classes in this examples. We have learned the rules of the abstract classes, and in future also we will be learning things like abstract classes. We will compare the abstract classes with the interfaces and how does this interfaces differ from the abstract class and all. So we will talk about those things in our later sessions. So if there is any doubt on the concept that we have discussed, you can ask it into the comments, and 100% you will get the answer to the questions that you are asking. So see you in the next video. For better reach, you try to share this with your friends and like and comment on the videos. Thank you. See you in the next session.